What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our lesson 7.4, properties of special parallelograms. We'll be able to use those properties to identify what they are, look at the diagonals, and then use coordinate geometry to identify special types of parallelograms. Today we're going to talk about rhombuses, rectangles, and squares. A rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles, and a square just has both of those, 4 congruent sides and 4 right angles. Looking at our theorem sheet, just want to make sure that we've just got these in the back of our brain. We know that a quadrilateral is a rhombus if and only if it has 4 congruent sides. It's just kind of repeating what we had from before. A rectangle, a quadrilateral is a rectangle if and only if it has 4 right angles. So we're seeing some pictures here of what those should look like. And then a quadrilateral is a square if and only if it is a rhombus and a rectangle, which means it has 4 congruent sides and 4 right angles. So what we're going to look here now is talk about a few of always or sometimes true statements. For any rectangle ABCD, decide whether the statement is always or sometimes true and explain your reasoning. So AB has to be equal to BC. Sometimes this would be true if the rectangle is a square. Okay, so if it is a square, then it can have AB equaling BC, but sometimes rectangles can't be squares and they wouldn't match always. Could AB then be equal to CD? Well, this one will be always, since it is a parallelogram. So opposite sides are congruent. So just understanding that A, B, C, D has to go in order here. A, B would then match C, D. Okay? Continuing on here, for any square, JKLM is always or sometimes true, that JK is perpendicular to KL. This is going to be always true since squares have 4 right angles. For any rectangle EFGH, is it always or sometimes true that FG is congruent to GH? So what I would do is just draw it EFGH. Here's FG, here is GH. That can be sometimes true if it is a square. And then the last one, a quadrilateral has 4 congruent sides and 4 congruent angles. Sketch a quadrilateral and then classify it. That would obviously need to be a square. Okay. Up next, we're going to look at 2 new theorems. The rhombus diagonals theorem states that a parallelogram is a rhombus if and only if its diagonals are perpendicular. So we're seeing that perpendicular relationship right here in the rhombus. And the rhombus opposite angles theorem just states a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So we're going to look at a few of those examples here. Finding the measure of the numbered angles in rhombus ABCD. So we have the measure of angle 1, angle 2, angle 3, and then angle 4. The first one I'm going to start with is angle 1. This one is a 90-degree angle because it is showing that bisecting the diagonals, and it's showing that 90 degrees and perpendicular. 2 and 3 are angle bisectors, and that would match the opposite angles here. So since we know C, this corner is 61, that means this opposite one is 61, and those are going to match. So both 61 degrees for 2 and 3. And then for angle 4, what we would need to do is, we know maybe that, think about this as like a triangle. We know that angle 1 is 90 degrees, angle 3 is 61 degrees, so what could angle 4 be if that's equal to 180, especially if we're thinking about as individual triangles? So 151 plus something equals 180, which means x will be 29. So that's just one way to find it. You obviously can use different ways of finding that too. as we continue on, we are going to talk about the rectangle diagonals theorem, and that's going to help us understand that a parallelogram is a rectangle if and only if the diagonals are congruent. So let's use this. You're building a frame for a window. The window will be installed in the opening shown in the diagram. The opening has to be a rectangle. Given the measurements in the diagram, can you assume that it is? We can assume it is based on the sides, but not necessarily on the angles. We don't know if the angles are 90 degrees. Okay? You measure the diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches. What can you conclude about the shape of the opening? So this would not be a rectangle since diagonals don't match. Okay? So what we're going to do here is practice that. It says in rectangle ABCD, AC is equal to 7x minus 15 and BD is equal to 2x plus 25. Find the lengths of the diagonals of ABCD. So those diagonals have to be the same if they're a rectangle. So 7x minus 15 has to equal 2x plus 25. Let's go ahead and move our variables to one side and our constants to the other. So I'm going to get 5x for this one, and then 10 for this guy. So x has to be equal to, or sorry, not 10, I subtracted those, 40. So x has to be equal to 8. So then I can just plug that into one of those expressions. I'll do 2 times 8 plus 25. That'll give me 41. Okay? The last thing we're going to do is decide if this ABCD parallelogram is a rectangle, rhombus, or square. So what I would first probably need to do is look at slope first, because I want to make sure they have the same slope to show that they are parallel. Okay? So maybe I do the slope of AB, and I'm just going to go from A to B. And since I have a picture, I'm just going to count rise over run. So up 1 over 1, 2, 3, 4. So AB is a slope of 4. And then across from that, I need to see, see maybe how BC is looking. Obviously, BC is not going to be rise over 1, 4. It's going to be up 1, 2, 3, 4 over 1. So it does show me an opposite slope, but it's not showing me perpendicular. So not perpendicular. So can't be rectangle or square. But in order to prove it could be a rhombus, I just got to make sure all of the sides have the same distance. So I'm going to use distance formula here. If you want to use Pythagorean theorem, you could as well. I just found distance formula was a little bit easier for me. Okay? So, distance for AB. That means I'm going to take my x's, 6 minus negative 2 squared plus 8 minus 6 squared. Okay? That'll be 8 squared plus 2 squared, or 64 plus 4. So AB's distance is the square root of 68. That just means in order for it to be a rhombus, everything else has to be a square root distance of 68. Let's start again with BC. BC, I'm going to do 6 minus 4 for my x's and 8 minus 0 for my y's. 2 squared, 8 squared. Again, I'm seeing 2 squared and 8 squared, so I know that's going to be the square root of 68. So far so good. So AB and BC are matching. Then I would check that with CD. I'm going to do 4 minus negative 4 and 0 minus negative 2. Again, I'm going to get 8 and 2 squared, which will be 64 and 4, which again, square root of 68. And then my final piece, AD, I'm going to do negative 2 minus negative 4 for my x's, squaring that, plus 6 minus negative 2 for my y's. 6 minus negative 2 is 8 squared. 2 negative 2 minus negative 4 is 2 squared. So again, I'm getting a 4 and a 64, which will be a square root of 68. So all of these have the square root of 68 as their distance. So that means I can say this is a rhombus, since all sides are congruent, but there are no perpendicular angles. Okay? That'll conclude our lesson on 7.4. Thanks again for tuning in. Hopefully this video helped you, and let's see you back next time when we talk a little bit more about parallelograms and how we can apply that to different types of quadrilaterals, especially with trapezoids and kites. Have a great day.